Now, using this unit circle, we can actually determine certain coordinates, ordered pairs of the points around the circles, related to some of the specific angles. And there's 3 specific angles that we'll be looking at. But before we get into that, I just wanted to take a look at some of the ordered pairs on the principal axes around this unit circle. Since we know that the radius is 1, if we start here and look at this point right here, that's on the x-axis where y is 0. Okay, anywhere along the x-axis, the values of y are 0. And because the radius is 1, if we were to spin this down here, and we know that the radius forms a circle of equidistant around about the origin, then that would mean that this point is 1, 0. If we spin it all the way around to the other side over here, well, it's still on the x-axis. Again, still y is 0, but now it's on the left side, or the negative side of the y-axis. Therefore, the x value is -1. If we stop halfway between the two x values, if we rotate just 90 degrees, or pi by 2 as they say in radians, then this point now is on the y-axis, and that's where x is 0, and so that would be 0 and 1 because the radius is 1. And then if we continue around here following the same pattern, that point is on the x-axis, sorry, the y-axis, meaning that the x value is 0, and because it's below the x-axis, on the negative side of the x-axis, that means that the y value is -1. So then by using this, we can then see that sine of theta, well, when the angle is 0, so if you haven't rotated anywhere yet, sine of 0 is going to be 0. And the cosine of 0 is going to be 1. We can rotate this up to 90 degrees, or what's also determined as pi by 2. Sine of 90 degrees. Well, sine of 90 degrees is going to be, well, it's the second coordinate, so it's going to be 1. And the cosine, because that's the first coordinate, that's going to be 0. Then we can just continue around, continue rotating around. So the rotation, I guess I was remiss in mentioning this, the rotation of this point on the end of the terminal arm, as it rotates up here, that's been rotated up through 90 degrees, which is a quarter of the whole way around the circle as you go through the first quadrant of the Cartesian plane. So that's 90 degrees. If we continue rotating around, well, then that's going to be halfway around the circle, which is 180 degrees. So the sine of 180 degrees, or what's also known as pi, is, well, it's the second coordinate again, so it's going to be 0. And the cosine of 180 degrees is going to be -1, because that's the first coordinate. And then we just continue rotating. Now we'll rotate another 90 degrees from 180. So we rotated all the way around here, and so now that's 270 degrees. So the sine of 270, well, we look at the second coordinate down here, and that's -1. And then again, we've rotated around 270 degrees. We look at the first coordinate, and so the cosine of 270 degrees is 0. And then just to finish off, we rotate back around to finish off the full 360 degrees. So the sine of 360 degrees is going to be, well, it's going to be back to 0 again, and the cosine of 360 degrees is going to be 1, because it's the first coordinate of that ordered pair.